So, hi guys. Today I'm going to discuss the question C strange function of Codeforces around 729. So basically, here you would be given with a number n and you need to find a positive integer x such that it is not a divisor of an ith number. And then you have to sum up all these x's for 1 till n, and that is our answer. So let me show you by example. So for 1, the minimum integer which does not divide 1 is 2. For 2, the minimum integer which does not divide it is 3. For 3, the minimum integer which does not divide it is 2. For 4, the minimum integer which does not divide it is 3. So basically, this we need to find for all the given numbers from 1 till n, and you would be given with this n. So for these type of questions you can clearly see that this is kind of observation based question. So for these you should write the answers for some smaller numbers and then conclude what could be the possible scenario or what could be the algorithm. So let me firstly write these numbers till 12. So for 5 it would be 2, for 6 it would be 4, for 7 it would be 2, for 8 it would be 3, for 9 it would be 2, for 10 it would be 3, for 11 it would be 2, and for 12 it would be 6. Oh, sorry, 5. So what you can see from here is that if any number is odd, you could see that its smallest is 2 only. So for this, what you could do is, suppose you are given with a number n, suppose say 9, anything. So what you can do is just find the seal of n by 2 and multiplied it by 2. This would give our answer for all the odd numbers between 1 to n. And now for all the even numbers, there is a pretty different scenario. What you could see is that for this 2, it is 3. For 6, this is 4. For 12, this is 5. And you could find a certain pattern that the factors of 6 are 1, 2, and 3. Factors of 12 are 1, 2, 3, 4. So the next minimum is 5. So the next is 4. So you could get an intuition from this, but to solidify this concept more, you could write few more numbers. And in actuality, I wrote those numbers till 60. And then what I found is that this 7. So when I when I wrote all the divisors of the 60, I found out like this: 1, 2, 3, 4, 5, and 6. So the next was 7. So basically, what I just found out is that for all the even numbers, at least 3 is coming in all. You could see that. At least 3 is coming in all. Whether it is 5 or whether it is 7 or whether it is 11, 13, anything like that. 3 is definitely coming. And then you could get some hints from this. Then could see that after 6, it's 4. After 12, it's 5. And when you would see this for 18, it would be 4 only. So after every 6 numbers, the even number which is coming is having an answer as 5, as 4. For every 12 numbers, it is 5. For every like 60 numbers, it's 7. So we could find out all these by just doing one simple thing, that we could assign all the even numbers firstly with 3 only, as 3 is the base number. So let me zoom out a little bit to create more space. Yeah. So now what you could see is that for 6 it was 4, for 12 it was 5, for 18 it's again 4, for 24 it's again 4. So what you could see is that after every 6 numbers there is at least one 4. Okay. So and what you could see is that for every after 12 numbers there is at least one 5. And this pattern would be observable in every numbers. Then after this and after the multiples of 60, for every multiple of 60, like 60, 120 would have 7 in them. So what I can say is that after putting all the numbers with 3, I could just iterate over all these numbers like n by 6 and add 1, add the number n by 6. This would ensure that for every n by 6 number, my 3 has become 4. Then I would add n by 12. What this would ensure? This would ensure that for every 12 numbers, my 4 has become 5. And for similarly for 60, if I would add n by 60, this would ensure that every 60th number has been to 7. And then here with the logic gets totally completed. So basically what's the observation is that for every number, suppose this is a number n, you take the LCM till 1 till x, any number x. Then if all these are factors of this n, then the x plus 1th number would be the answer for this f of I that was written in the question. So I would need to just do this. So let me show this in the code. It would be pretty easier to understand by that. So basically this is just the test cases, and here I go. I would just take the number n. This is just the ceil function. If you don't know, let me tell you this also. Basically, ceil of a by b could also be written as a plus b minus 1 by b. So similarly, ceil of n by 2 is just n plus 2 minus 1 by 2, which is n plus 1 by 2. So I just did that. And this is for the base, what I told you earlier, that I would enumerate all the even numbers with firstly 3. And then as you could see that our base numbers from where the situation of different numbers other than 3 arised was from 6. So I basically took the LCM as 6, and then when you would enumerate all the numbers for finding till what the maximum numbers for what the maximum value fi could reach is, it could reach up till 41. So I just, for the sake of completeness, I just took it to 42. Basically this 41 arises from the fact that the numbers are up to 1 16. Okay, so let me tell you this also, otherwise it would not be complete. So basically to find out this, what I did, I just took a calculator and just manually calculated for which numbers I would need a number greater than a certain number. Like for which I would need 2, for which 3, for which 4, and then till I enumerated till 39, my number was something reaching sort of like 114 or 15, I just can't remember what it was. But after this, as I took 40 or 41, it just came out to be greater than 116. So I basically just found out that the maximum fi could reach is till 41 only. So this is just the basic thing. So let me go further. So yeah, so for basic purpose, I just took LCM equal to 6, and then for every number, I firstly did this n by LCM. So basically here the LCM was 6, so basically it would make all the multiples of 6, which were 3 to 4. And then after this I just calculated the next LCM into the current number, which is 4. 6 into 4, 24, by GCD of 6 and 4, which is 2. So this came out to be 12. So when this loop would run again, I would add n by 12. So basically this would encounter for 5, and similarly for 7, say 8, 9, 13, 14, for every number. And then I would just print the sum. So basically the mod here is defined. Yeah, here it is defined. So basically this completes the solution. So hope you liked it, and thank you.